Alright, this video is for some math help for 070207G. That's the trig book stainless steel miter. Okay, so the first question in the exercises is just asking you to identify the sides of the triangle. So the first one, this hypotenuse, remember that's always the longest side across from the right angle. So there's the right angle. Okay, that is the hypotenuse, C. The adjacent side is the one beside the angle. So I guess that'd be C, that'd be A. And the opposite is the one across from the angle that you're kind of looking for. So that would be B. Okay, and there's a bunch of questions in your self-test. I'm not going to bother going through them. Just follow the same things that I did here, and you should be fine for all of those. Okay, so for exercise 2, what they're asking you is to find the angle. So there is trig books and trig charts. There's some in your IPT. There's even some in your ILMs. It's a little bit easier just to use your calculator. So again, I'm going to use the Casio FX260. And how I do this is I just go point, like for this first one for A, I will go 0.5774, and I'll just go shift tan, and I should get 30.00213698. Okay, we'll just round and say it's 30 degrees. Okay, and I'll do a tan. I'll do another. I'll do B. I'll do cos there, so it's 0.342, and again I just go shift cos, and I should get 70 degrees. And I'll do a sine. I'll do C. So it's 0.573 shift sine, and you should get, I'm going to say 35 degrees. Okay, so that's really all there is to it. Again, I don't think I'll do all of them because it doesn't really make sense to do all of them. It's more just more of the same here. Oops. Okay, so for exercise 3.1, again, you can use your IPT handbook to find the trig tables. I'm just going to use the calculator because it's a little faster, a little bit easier, and chances are if you're ever using this in the field, that's what you're going to use. Okay, so how I do this is I just go 10 tangent. So again, I just put 10, then the tangent button. I don't have to push equals, and I should get 0.176. 326. I'll just say 3. Good enough. Should be a point right there. Okay, for the sine, I'll just go 10 sine. I don't have to push equals, and I guess it's the same number. 1736. I guess it's a little bit different. And then for 10 cosine, again, I'll just go 10 cosine. I get 0.98480. Okay, so again, you can just go through the chart doing the same thing. So it's just the degree, then the trig function. Okay, so for exercise 3, question 2, now we're starting to use some trig here. So again, the first thing I do is I'll solve A, I guess. The first thing I do is I ask myself, what sides am I working with? So I'm working with the opposite side. That's this one, opposite, and the adjacent side. So I guess I better write down SOHCAHTOA. SOHCAHTOA. Oopsie. Oh. Whoops. Okay, what sides am I working with? I'm working with the opposite and the adjacent. So that's going to be tangent down here. So if the tangent of x is equal to the opposite, which is 185, over the adjacent, which is 420. Okay, so again, I just go 185 divided by 420 equals shift tangent. Okay, and you should get 23.772 degrees. I'm just going to round up and say 24. Okay, so it'd be 24 degrees. Okay, to do B, I guess I better follow my own advice, right? SOHCAHTOA every time. SOHCAHTOA. Okay, so for B, what sides am I working with? I'm working with the hypotenuse and the adjacent. Hey, that's going to be cosine. So it'll be cosine of x is equal to the adjacent, so that's 480 over the hypotenuse, which is 610. So I just go 480 divided by 610 equals shift cos, and I should get 38.1046 something or other. I'll just say 38 degrees. 38 degrees. For this one over here, now we're going to have to find the side, but I kind of do the same thing. I'll write down SOHCAHTOA. Okay, what sides am I working with? That's the opposite. That's the hypotenuse, so I'll be using sine. Opposite and hypotenuse. And I write the sine of 48 is equal to the opposite that I don't know, so I'll just say B, over the hypotenuse, which is 550. Okay, so if I'm trying to find this one on top, then I just multiply those two together. So I'll go 48 sine times 550, and I should get 408.729654. So again, I'll just round up and I'll say it's 409. Okay, and then the last one, I guess I'll do the same thing, follow my own advice. SOHCAHTOA. What sides am I working with? I'm working with the adjacent side and the hypotenuse. Okay, that's going to be cosine. So cos of 65 is equal to the adjacent, which is 8, over the hypotenuse, which we don't know. Okay, so how I figure this one is, I just go 8 divided by 65 cos. So 8, here's my calculator, 8 divided by 65 cos. And don't forget to push equals. And you should get 18.929612667. Okay, and normally if it's in inches, then I should answer to the nearest 16th of an inch. So how I do that is I take away the whole number, so I'll just go minus 18, and I'm left with the 0.929612667. I times that by 16, and I get 14.8, or I'm just going to round up to 15/16. Okay, so it'd be 18 and 15/16. That's supposed to be a 16. Okay. Okay, so for objective 2, question 1, now we start getting into calculating the cutback and the lengths of both A and B's for a three-piece mitered fitting with a radius of 300 millimeters. Okay, so I'm going to try to draw this out, and it's probably not going to look very good. Not my best, but that's okay. So again, that's an A, that's an A, that's a B. Remember, the B's are just two A's, right? And we're told that this distance is 300 millimeters, 300. And the outside diameter is 89 mil. Okay, so first thing we got to do is we got to figure out our miter angle. So it'll be this. That's what we're trying to figure out. Just like that. Okay, so how we do that is we're told that it's a 90. So again, I do this a little bit differently than your book, but I go 90 divided by the number of welds, which is 2, divided by 2. So 90 divided by 2 divided by 2. 22.5, so that's my miter angle, 22.5. Okay, and then to find A, again, I guess I could put an X. I guess the A is pretty much that I could just do that. I know that this angle is 22.5 degrees. Okay, so now I can just use trig. Again, which sides am I working with? Well, it'll be the opposite and the adjacent, so that's going to be tangent. So I just go to the tangent. 22.5 is equal to the opposite side. That's the side we don't know. I'll use A over the adjacent, which we're told is the radius of 300. 300. Okay, so again, if I'm finding this one on top, then I just multiply these two together. So it'll be 22.5 tan times 300. Times 300. And you should get 124.264, a bunch of stuff. It's millimeters, so I'm just going to say it's 124. 124 millimeters. Okay, remember the B's. The B's are just two ways, so I can just go 124 times 2 times 2. And, too bad with rounding. So I did not clear my calculator, and I just multiplied by 2, and I got 248.5. So that actually rounds up to 249, which is different than the book. So if you don't clear your calculator and you go times 2, you'd probably get 249 or 248.5281,374. Your book just used this number times 2, so I guess that's what I'll do too. And you'd get 248. Okay, and if you got 249, you're probably, I guess you're not right. I guess you would be more right because it's 0.52, so you're a little closer. But anyways, we're not going to argue over 1 millimeter. Okay, so A 124, B 248. Okay, your cutback distance. So remember your cutback distance is because that measurement, that 124 is to center. So again, you'd have a piece of pipe like this. You give yourself a wraparound mark. You got to figure out your cutback distance like this, so you can, so you can give yourself the proper miter. Okay, so there's a couple ways I could do this. I guess they're kind of both. I think I noted this the same way as your book, but the quick and dirty version is we kind of use the same idea as this down here. So I'll just go. Let's see if I can squeeze it in down here. Tan at 22.5 is equal to I don't know, over the outside diameter, which is 89, and then I divide the whole thing by 2. Okay, so I can just go 22.5. 22.5 tan times 89. So times 89 equals 36.865, and I divide it by 2. And I get 18.43. So my cutback is, I'm just going to say it's 18 millimeters. Okay, so what I actually did is I kind of went, I figured out, kind of went through like this, if that kind of makes sense, and figured out the whole thing. I then divided by 2, if that makes sense. So you could have went tan 22.5 times 89 divided by 2, or you could have went 89 divided by 2 times the tangent of 22.5. Like either way, you're going to get 18.4 mil. Okay, objective 2.2 or question 2. So it looks like it's a 4-piecer. 4-piece. I'll try to draw this out as best I can. Oh, this is getting bad. Okay, there's my 4-piece. And again, we got A's here, B's on the middle. And remember, A's are half the size of B, or B are 2 times A's. Okay, oh, this looks like a weird one. It's a 78-degree 4-piece with a radius of 20 inches. So I guess I should draw that in. 20 inches. Okay, so the first thing I have to do is find my miter angle. And again, how I do it is a little different than your book. I just go 78 divided by the number of welds. 1, 2, 3, divided by 3, divided by 2. Your book would go 78 divided by 3 times 2. Either way, you'll get the same. You'll just have to use, yeah, doesn't matter. Anyways, 78 divided by 3 divided by 2 should be 13 degrees. 13 degrees. So I can draw that in now. So it'll be the tan of 13 is equal to A over 20. Okay, so again, if I'm figuring out A, then I just multiply these two together. So it'd be 13 tan times 20, and should be 4.617363 something something something. So again, this is in inches, so I probably want to convert to 1/16 of an inch. So what I do is I subtract the whole, minus 4, and I'm left with the 0.617363822. I multiply that by 16, and I get 9.8 something or other, so it rounds up to 10/16 or 5/8. So the right answer would be 4 5/8. Okay, remember the B's. The B's are just 2 times A's. So if I go 4 point, I should get 9 1/4. 9 1/4 inches. Okay, so it's just 4 5/8 times 2. Okay, so for the cutback, remember I got a couple ways I can do it. Here's my outside diameter. What I like to do is I just go the tangent of 13 is equal to I don't know over my outside diameter, which is 3.5, and divide that thing by 2. Or it's kind of sloppy notation. I should have wrote it differently, but you guys get the gist of it. So it'd be 13, here's my calculator, 13 tan times 3.5 equals, divided by 2, equals, and I get 0.4040. Remember, that's in inches. I probably want to convert it to 1/16 of an inch, so I times it by 16. Okay, and I should get 6/16 or 3/8 of an inch. Okay, so it's 6/16 or 3/8 of an inch. 3/8 of an inch. Okay, I could have also gone tan of 13 times, or sorry, I could have went 3.5 divided by 2 times tan of 13. Either way, you should get 3/8 of an inch. Okay, so now we're moving on to the self-test questions. Okay, so the first one is we just got to figure out the angle. Looks like they're, oh no, angle and side. Okay, so I'll just do a couple of them. I'll do maybe just the first one. Oops. I'll do the first one. And I'll do every second one. How about that? Okay, so we're going to the nearest half a degree or millimeter or 1/16 of an inch. Okay, so the first one, we're going to find this angle right here. So it's, first thing I do is write down SOHCAHTOA. What sides am I working with? Well, I'm working with the opposite and the adjacent, so that's going to be tangent. So it's the tan of x is equal to the opposite, 27 inches, over the adjacent, which is 34. So you just go 27 divided by 38 equals shift tan. You should get 35.4 degrees. Oh, sorry, I messed that up. Look at me. That should have been 34. My bad. Let's erase this out. Okay, so it should be 27 over 34. There we go. 27 divided by 34 equals shift tan. It should be 38.4. 5. Okay, so that rounds up to, I guess they want nearest half, so it'd be 38.5 degrees. 38.5 degrees. Okay, C. So again, I'm trying to find an angle. What sides am I working with? Well, I'm working with the adjacent side and the hypotenuse, so that's going to be cosine. So the cos of x is equal to the adjacent, so that's 1405 over 1500, that's the hypotenuse. So I just go 1405 divided by 1500 equals shift cos, and I get, hey, 20.5 on the money degrees. Okay, let's do the last one here. I'll do this one right here. So here I got to find the length of B. So what sides am I working with? Well, I'm working with the adjacent and the hypotenuse again. So that'll be cosine. So it'll be the cos of 67.5 is equal to the adjacent side, which is B, over the hypotenuse, which is 840. So again, to find B, I just multiply these two together. So it'd be 67.5 cos times 840, and you should get 321.45 something is saying the nearest millimeter, so I guess it's just 321. Oops. Okay, self-test number 2. So here we got to find the cut angle and the cutback for a 2-piece miter. Oh, they're telling you the angle is 15. Oh, that's nice of them. 15 outside diameter of 20 to the nearest half degree and nearest 1/16 of an inch. Okay, so I'll try to draw this out. It's going to look a little bit funny, but whatever. Okay, and they're not giving us the radius because I guess we don't need it because we're not finding the A's and the B's. Okay, so to find our cut angle, again, it's just the degree divided by the number of welds divided by 2. So it's just 15 divided by, there's 1 weld, divided by 2 equals 7.5 degrees, 7.5 degrees. Okay, and for the cutback, again, how I do it is I just go, if you want to learn how I do it more in depth, you can rewatch the lecture video, but I just go the tangent of, oops, screwed this up already. So I just go the tangent of 7.5, because that's our cut angle, equals, I don't know, over the outside diameter, which is 20 inches, and I divide all of that by 2 there. Okay, so how I solve this is 7.5 tan times 20. Okay, and that equals 2.63 something or other. I divide it by 2. And you should get 1.3165. This is going to be in inches, so I guess I should convert it. But I got 1.3165 to something inches. I subtract the whole, minus 1, to leave me with all the stuff after the decimal. I times that by 16. And you should get 5/16. Inch and 5/16. 5/16. Okay, self-test question number 3. Here I'm asking, or it looks like the ILM's asking for the cutback, the lengths of the pieces of A and B, and okay. So it's a 5-piece. Wow, this is going to get messy here. 1, 2, 3, 4, 5. Okay, this is not drawn properly. Don't hold it against me. Okay, and our radius is 750 millimeters. Okay. Boom, boom. And our outside diameter is 819 mil. Okay, so again, here I'll draw this. I'm going to use trig to figure out this one. So the ones on the outside are the A's. There's an A, there's an A. These ones are B's. Okay, remember B's are just 2 A's. Okay, so the first thing I got to find is my cut angle. So it's 90 degrees. 90 divided by the number of welds. 1, 2, 3, 4 welds. Divided by 2. So 90 divided by 4 divided by 2 equals 11.25 degrees. Okay, so that tells me that this angle right here is 11.25 degrees. And now I can just use trig to figure it out. Okay, so it's tan of 11.25 degrees is equal to the opposite that we don't know. That's A over 750. Okay, so we'll just go 11.25 tan times 750 equals, and I should get 149.1842755. It's millimeters. It says to the nearest mil, so I'll just say 149. 149. Remember, piece B is just 2A, so I go 149 times 2. 149 times 2, and I should get 298. Okay, and to find my cutback, how I do this is I just use the same angle, so it's tan of 11.25 is equal, I don't know, over 819 divided by 2. Okay, so it'll be 11.25 times tan Whoops, screwed that up. 11.2510 times 819 equals 162.9 or something like that, divided by 2. Okay, and I should get 81.4561444. Again, it's just the nearest millimeter, so let's be 81 millimeters. Oh, I guess that's it. Okay, hopefully that video helps you out.